All right, what's going on, guys? Hey, Unit 9 is in the books. Unit 10 is in the books. We're now moving on to Unit 11, all right, which we're going to look at exponential functions, growth and decay, a little logarithm, a little transformation, a little solving. All right, so let's get started. All right, so guys, right here we have, again, exponential functions, growth and decay. How can equations describe growth and decay situations? Write and evaluate exponential expressions to model growth and decay situations. All right. So growth that doubles every year can be modeled by using a function with a variable as an exponent. This function is known as an exponential function. Oops, misspelled that. There we go. Exponential function. All right. And then it says the parent exponential function for f of x is equal to b of x. Now, guys, the parent function is just the base and the exponent. All right. Nothing else. Where the base b is called the constant. All right. And the exponent x is called the variable. All right. Now, here it is, right? The base b, the exponent, the variable, okay? Now, right here, it says the graph of the parent function, f of x equals 2 to the power of x is shown. The domain is all real numbers, all right? Make sure you understand that. That's important, guys. All right, the domain is all real numbers, and the range is y is greater than 0. There's your range right there. And remember that the domain is all real numbers. That will be on the test. The range, y is greater than 0. All right, look at that. It will never go. See that line right there? Hear me. This line will never, ever get below that x-axis, which is y equals 0. So you actually have an asymptote. Remember that word, asymptote? All right, asymptote. Asymptote, all right, and in this case, the asymptote is y equals 0. All right, y equals 0. All right, it will never pass that line right there. It's a horizontal asymptote, okay? Like, see this right here? See as the values get smaller? All right, as the values get smaller, all right, as the x values get smaller, the fraction will continue to get smaller and smaller and smaller, but it'll never stop. All right, which brings me down here to this next value. It says, notice as the x value decreases, the function never reaches the x-axis because the value of 2 to the x cannot be 0. All right. In this case, it is called an asymptote. All right. We just typed that. All right. It's called an asymptote. All right. As an asymptote is a line that the graph function approaches as the value of x gets very large or very small. What is the end behavior of this graph? Well, as x goes to positive infinity or to the right, as it goes to the right, we say that the function, as it goes to the right, it is going up to positive infinity. That is the wrong key right there. Let me change the pen. We go up to positive infinity. All right, and as this goes down, as it goes to the left, right? See, as it goes to the left, negative infinity, that way, this approaches 0, but it will never pass 0, okay? Now, a function of the form ab to the x, all right, that means a number times b times the base raised to the power of x, as a is greater than 1, all right, if a is greater than 0, so any number greater than 0, all right, but b is greater than 1 is an exponential growth. So let me type that in right there, exponential growth, all right, and when b is less than 1, all right, less than 1 but greater than 0, like a fraction. All right, a fraction that's less than 1, like 3/4, 1/2, 2/5, stuff like that. That's less than 1. It's going to be an exponential decay. All right, exponential decay. And there are your rules right there, okay? So let's go ahead, turn over, look at our next page. All right, it says, tell whether the function shows a growth or decay, then graph. So, right here, we're going to look at B. All right, look at B. Here's our equation. This is A, this is B, all right, and the exponent is X. Well, again, see B is 3/4. B, in this case, is less than 1. All right, but it's greater than 0. So when it's that, let's go back to the notes on the front, right here. All right, or right here, growth decay. All right, when b is less than 1 or greater than 0, you have a decay, exponential decay. So let's go back over here. All right, so we have a decay. All right, it says find the value of the base. The base is 3/4 is less than 1, therefore the exponential decay function. It says then graph the function, which we're going to graph in a second. Okay, well, let's go to graph it right now. So I'm going to go to my calculator. I'm going to type that in. I'm going to show you how to do it right here. All right, what we have right here is, all right, we have y equals. You go to y equals, and you're going to graph these things. And we have 10 times 3/4, 3 divided by 4, raised to the power of x, like that. All right, and then we hit graph. There we go. There's our decay right there. Okay, there's our decay. So look, I need to pick some points. All right, let's see what points I can see from a graphing standpoint that I could use. All right, so 0, 10. I will use 0, 10. What else can we use? Man, none of these are any good. All right, so I'm completely about to wing this graph, and I'm all right with that. Go back up real quick just to see. Man, this guy's riding around on his daggone car in the gazebo. All right, anyway. All right, back to our graph. So we have 0, 10 right here. All right. And then we have, those are about 6, 8, 8. All right, and I'm going to do it like that. Oh, there we go. All right. Now, asymptote. Guys, remember the asymptote is y equals 0. All right, because look, this will never cross this line right here, the x-axis, which is y equals 0. The intercepts, guys, well, we have this intercept right here. All right, hold on. Let me go back to it. Actually, I'm not going to go back to it. The intercept is easy to find. Think about it. If you remember the rule, anything raised to the 0 power is always 1. So if I went 10 times 3 to the 4th raised to the 0, well, think about it. The x value is 0, and then the y value would be what I get as my answer. So right here, 3 to the 4th to the 0 power is 1, so that's 10 times 1, which is 10. All right, that's my y-intercept. Now, in behavior, as x goes to the negative infinity, that's to the left, it's going up to positive infinity. And then as x goes to the right to positive infinity, the graph is going down to 0. Now the domain, guys, for exponential functions are all real numbers. And the range is y. Remember, that's the asymptote. It can't pass that. So y is greater than 0. All right. Now let's go over here to this word problem. It says, example 1b, 100 times 1.05x. Remember the rule, we look at b. In this case, b is greater than 1. All right, b is greater than 1. So that means it's an exponential growth. All right. So, and it says it right here too, exponential growth. So I go, this is a growth. Now I need to graph it. All right, and I'm going to graph it. I know that there's a value right here. Use your calculator, but there's a value right here. Remember the asymptote, how to find your intercept. You make x 0, so you have 100 times 1.05 raised to 0. Well, my x value is 0. And then 1.05 to the 0 is 1. 100 times 1 is 100. So there's my y-intercept. So there we go, 100. All right, and I'm just going to, it just keeps going, guys. Oh, that's a terrible drawing, but you get the idea. All right, asymptote. Y equals 0. As x goes in behavior right here, as x goes to the left, the function approaches 0. And as x goes to the right, this thing is going up to positive infinity. All right. And then the domain, remember, all real numbers. The range, y is greater than 0. It's greater than 0. It goes up from there. And lastly, right here, a U-try problem. 1.2 is greater than the b value is greater than 1. So it's a growth. All right. And then for my intercept, remember x is 0. So it's going to be 0, 5. All right. Just plug that 0 in right there. All right. 1.2 to the 0 is 1. 1 times 5 is 5. So 0, 5 is going up. It's a growth. So right there. All right. Asymptote. As s goes to the left, the function goes down to 0. And as s goes to the right, the function goes up to positive infinity. The domain is all real numbers. And the range is going to be y is greater than 0. Remember, it can't go past the asymptote. But hey, man, real short, real simple. Man, well under 15 minutes. I'm happy. I hope this video helps, and I will catch you later.